Okay, so this next one here, looking at this, we can solve this by factoring. Okay, but before we factor, we need to see the terms that are the same. So I'm going to convert that tan into sine x over cos x minus sine x. And since it's equal to 0, that's perfect. I can factor out the common sign. And then I end up with 1 over cos x minus 1 equals 0. Okay, so solve each factor independently. So sine x equals 0. Okay, so sine x is equal to 0. Just going to draw the picture over here. Sine x is equal to 0. Sine is y. So we have two solutions, one here, one here. Okay, so we're going to end up with the angle x equals 0, pi, 2 pi, dot, 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 dot. So we're going to generalize that as x equals n pi. Okay, for this solution here, I'll do this in a different color. So for this one here, we're going to end up with cos x equals 0. Sorry, cos x equals 1. Okay, so then drawing the picture for that, cos x equals to 1 at this point here. Okay, and that's the only point, so we get x is equal to 0 and then 2 pi dot 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 dot. So these are redundant, so they are overlapping solutions, so we're just going to stick with this one solution here. Okay, so that represents all the solutions. These end up being repetitions of these solutions here. Okay, so this one here, we have, let's start off by getting rid of the extra 2, because we can divide both sides by 2. We get e to 2 sine squared x minus sine x minus 1. Okay, and that's going to be equal to, that will be equal to 1. Okay, so what does this mean? Well, I need some exponent on e that's going to give me 1. Okay, so I could use a log to solve this. Basically, we get log 1 equals the exponent. But log 1 is 0. Okay, so basically the exponent has to be equal to 0 for that to equal 1. So we end up with 2 sine squared x minus sine x minus 1. That's equal to 0. So I can factor this. So I end up with 2 sine x. That looks like it's going to be plus 1. And then sine x minus 1. And that's equal, I've already got it equal to 0 there. Okay, so then I can solve these two equations independently. Here I get sine x equals negative 1/2. Okay, so I could draw a picture for that. Sine x equals negative 1/2 is going to be in quadrants 3 and 4. Here and here. Okay, so that angle is going to be x is equal to 7 pi over 6. And the other angle is 11 pi over 6. Okay, so then this solution here, this is going to be when sine x equals 1. So sine x is equal to 1 at the very top. Okay, it's only one point on the circle at pi over 2. So x is equal to pi over 2. Okay, so there's 3 unique solutions. Now the period of this is 2 pi, so these are going to repeat themselves, n 2 pi. Okay, so plus n to pi, where n is an integer, plus n to pi. Okay, so there it is. Those are solutions. So again, we had to solve for the exponent first, and then we can solve for the quadratic here.